Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Go ahead.
Hi everyone. So thank you for joining this session. And today I'm going to speak about the topic called as slash costs and boost efficiency, Carpenter's secret to Kubernetes autoscaling. So this is a topic I'm going to talk. And before we get into the topic, let me introduce about myself. I am Nagababu Medicharla, and I am a solver at CS. CS is an AWS Advanced Consulting Partner. So I am a community builder and ex-ambassador, and also a prospect ambassador now. Um, and I am having more than 9+ AWS certifications, and I'm a Gen AI enthusiast. So I help many startups, fintech, and other customers migrate to AWS and modernize their respective workloads. So the agenda for today, what I am going to talk about is about the EKS architecture, and then followed by horizontal pod autoscaler, then what is cluster autoscaler and Carpenter and demo. So without wasting much of our time, let's get into the topic. So for I think most of the people are already aware of EKS cluster architecture, but in the interest of the people who doesn't know, I have got this slide. So usually what happens when we are talking about EKS cluster architecture, right? So in the left hand side, you're having EKS VPC. That is where your control plane resides. So control plane is the heart of your EKS cluster where all your cluster admin activities happen. So something like the API controller or the etcd cluster and other admin controllers, right, will be placed in the control plane. To your right hand side, we are having workload VPC. That is where our, which we call it as a data plane as well, that is where our respective EKS pods will be residing. So if you see, we have this workload VPC is in our control, where we will be going and creating the respective workload VPC, and we will be deploying the EKS cluster. While deploying the EKS cluster, you're having different options when you're going to deploy. So one of the option, right, is where you can go and create your own. Create your self-managed EKS nodes, where you are responsible for patching of the respective nodes and also taking care of joining that respective node to EKS control plane. There is a better way of doing that, and that is called as manage node group, where AWS takes care of everything from scaling and also the respective. It also takes care of the patching and so on, all the administrative tasks, right? It takes care. We also have Fargate profile. It is which is a serverless containerization. We can also get Fargate behind the EKS cluster. Apart from this, we are also having two other types, which is used for hybrid environments. One is EKS Outpost. Outpost is nothing but an extension to your data center, where AWS will be residing in your data center and residing on the AWS provided dedicated hardware. So you can get that outpost deployed, shipped to your data center, and you can start using. There is another thing called as the there is another thing called as EKS Anywhere. So what does EKS Anywhere does is it's an open source EKS distribution that is available, where you can deploy on your respective data center. So these are the five ways, right, in which we can get the EKS cluster, EKS node groups deployed. Apart from this, what which makes EKS very much stable is where it also supports multiple add-ons integrations. So if at all you take primary add-ons, right, something like EBS, EFS, or the control, the CNI drivers and so on are all coming under primary add-ons. You are also having continuous delivery where you can also leverage Helm or Argo CD. And coming to ingress is you can also leverage in the load balancer controller, or you can also use Nginx there. For observability, we are having Grafana, Lokit, KubeCost, Prometheus. All of these are available as add-ons where you can go and integrate, and all of these are open source. Coming to the last part is autoscaling. This is where we are having Karpenter, and even right there are other open source projects that are available. So something like Keda. So this is what makes EKS very much friendly to use, because it also supports integration with multiple CNCF open projects as well. So that is about the EKS architecture. So we will get into next. Suppose let's imagine you are having your respective pods deployed. So how does the traffic? How does it look like? You're having in the left hand side where you're having an EKS cluster. Inside the EKS cluster you're having nodes. Usually, right, nodes will be so inside the node group you'll having nodes, and nodes are nothing but they will be available inside the node group. So inside the node you are having pods. This is where you will be actually deploying the pods. So inside the pods you will have the container. So this is how, right, the hierarchy of EKS objects are there. So first in the left hand side, coming from left hand side, right, you're having EKS cluster, nodes, pods, and pods contain containers. Now coming to the traffic flow, how does EKS traffic flow happens, right? Your users will be hitting the respective load balancer, and load balancer will consist of EKS service. So EKS service will be having the pods behind it. So this is how the traffic flow of the respective in the EKS cluster, right, behaves. Now coming to this auto scaling, we are having two types of auto scaling. When I talk, right, at a pod level, and another one is at a node level. So pod level, right, what happens is we will be configuring horizontal pod autoscaler. That means we will be giving, if at all you see you're having in the definition file min replicas and max replicas. That means if suppose the CPU or memory of the respective pod is increasing immediately based on the threshold that you are defining here in the horizontal pod autoscaler definition, your pods will be added. That means to the same application, what is happening is you're adding multiple pods in order to balance the load. So this is at a pod level. Now let's say what will happen is, now let's say, right, if suppose you're having the pods already deployed, and node contains some capacity. So node, right, has some CPU and memory associated with it, and pods can go on scale as long as there is enough enough resources available on that particular node to spin up. So if suppose there are no nodes, what will happen is the pods will not be scheduled. If at all you see, I have got a sample application deployment which is having 5 replicas. If at all you see, one out of five, right, three are scheduled, and Nginx deployment one of one, zero of one, zero of one, and one of one. That means out of five, I am able to run three pods, but two pods are not running. If at all you go on, if at all you go and see the respective uh, description or of the logs, it is saying that nodes are available, three insufficient CPU preemption. That means zero out of three nodes are available. So what it is saying is you are not able to deploy any more pods because you don't have your resources to deploy that. So that is where, right, the autoscaler comes into picture. So that means node autoscaling comes into picture. So in the last slide, what I told is how you can do a pod autoscaling. Now what we are going to talk about is the node autoscaling. There are two mechanisms that are available. One is the cluster autoscaler, and there is another better way where we are going to talk about Karpenter. So cluster autoscaler is nothing but it comes by default with the node group. So cluster autoscaler, right? What usually happens is, if suppose let's imagine you're having three nodes, one each of M5 large, M5 large, M5 large, and if suppose a new pod has to come, then immediately what will happen is AWS cluster autoscaler will add one more node of the M5 large. So now what is happening is, even though you're going to schedule one pod also, you're getting the you're creating another M5 large instance. So for only one pod, you're creating this big instance. So what if there is any other better way which we can do this? And also cluster autoscaler, what it does is it makes use of the autoscaling group. Usually autoscaling group it will be a bit slower because it depends on the autoscaling group events. So it takes some time to identify that there is an autoscaling event, and then it will trigger a new node added to this. So this is how cluster autoscaler works. But if at all you see, for even one pod, you're getting an same type of instance. That means M5 large, M5 large, M5 large. That means you cannot get more than one, or more than, sorry, you cannot get multiple node types in the cluster autoscaler. Okay, so this is where, right, what is happening is Karpenter comes into picture. Karpenter, what it is, an alternative to Kubernetes autoscaler, and it can span, it can create, nodes based on API action. It's not based on autoscaling group. So this is so we can add node or remove a node in no time. It will be very fast. So that is how we are actually getting that respective node autoscaler a bit efficient. And also what it does is it helps in cost optimization. So how does it help is, it will not make use of the same type of EC2 instance that will get launched. In the cluster autoscaler, what we did is we are getting the same type of EC2 instance launched, right? Here we will be defining 4 or 5 EC2 instances, something like a family, based on your input. So if suppose your pod requires, in order to get scheduled, if it requires one CPU, one memory, 1 GB memory, it will launch only one CPU, 1 GB memory instance. It will not launch something like 4 CPU, 8 GB memory. So that is how, right, it is actually ensuring that your respective costs are within the limits. Okay, so now how does Karpenter work, right? So horizontal pod autoscaler, what it does is it will create a pod because, let's imagine there is a threshold it has reached. Immediately it will create a pod, and usually pods will be in the pending state. So before Carpenter, what used to happen is it used to take the Carpenter used to take sorry cluster autoscaler used to take the control, and it will add, by using autoscaling group, it is adding an ECT instance of the same type. Okay. Now, what is Carpenter going to do is, Carpenter will come into picture and it will treat. Okay, so you're having suppose two pods running. How much memory and how much CPU does this two pods require? Okay, these require two CPU, two 4 GB memory. So it will make use of that configuration, which is having the similar two CPU and 4 GB memory, and it will launch the EC2 instance. And this is an API action. It's not direct. It's not using an auto scaling group. So this is very quick. Okay. Now there is one more important factor which actually is very important is Carpenter optimization. So this is where, right, it will be helping us to save lot of costs to your existing clusters, EKS clusters. So let's imagine you're having four nodes, M5X large, M5X large, M5X large. So if at all you see, in the first node, you're having four pods scheduled. In the second,
1 minute left.
okay, in the second node, you're having two pods. In the third node, you're having one pod. So usually, what happens is Carpenter optimization will, okay. There are some resources getting wasted here, and it will immediately optimize that. It will get all of the pods into one node. So that is how, right, the cluster optimization helps in. Okay, now how does this, how do you define all of this, right? Is there is a YAML file called as nodepool.yaml file, in which you will be giving. So I wanted to create C family, M family, R family, and you can also leverage even the multiple types of instances. You can also launch spot instances and on-demand instances as well. So that is how, right, this is very useful. So what I'm going to do is I'm just going to present you. See, uh, I'm having an EKS cluster. One second. I'm having an EKS cluster. So before I have deployed even already I have deployed already the Karpenter, and if at all you see at the moment the number of replicas, the respective deployment is requesting for one CPU and 1 GB memory. At the moment the replicas are 0, and I'm making them 5. Okay, so now once I make them 5 and schedule it, what will happen is immediately they all of the nodes, right, are in pending state, and what will happen is kubectl get 0 out of 2 are available to insufficient CPU. So immediately what will happen is another node will get added. So when I started this, I'm having only one two nodes. Now when I go and create, so if at all I go to the Karpenter logs, it is actually seeing how many respective how much is required, and it is adding the respective nodes. If at all you see, okay, now there are I was initially having only two. Now I have got four nodes. If at all you see, only two were there previously, and it launched one more node, and it is of 6A 2x large.
Please last 30
Yeah,
seconds.
so that is how, right, this is very useful. And how I defined is by using the nodepool.yaml file. So I can provide all the resources to you guys, but at the moment, in the interest of time, right, I'm moving ahead as part of the demo. So, so I am done. So any questions?